morning, everyone. I'm Uma Maheshwari, APEEE Department, RMT Engineering College. This video, I'm going to discuss about the subject sensors and transducer. In that, Unit 3 is the force, magnetic, and heading sensors. So, in this unit, we're going to discuss about the subject topic, all effect sensors. The all effect sensors is the sensor which is used for detecting the practical behavior of the circuit, any circuit such as motor, in response to the changing magnetic field. The All effect sensor is the transducer where the voltage varies by changing the magnetic field. This sensor, it consists of a metal strip. When it is placed inside of any magnetic field, then the presence of this magnetic field electron is deflected towards the edges of this strip. Then EMS is induced across its edges. All of its sensors are devices which are activated by external magnetic field. We know that a magnetic field has two important characteristics. One is flux density and the polarity, north pole or the south pole. The output signal from all of its sensor is a function of magnetic field density around the devices. So when the magnetic field density around the sensor exceeds a preset value or threshold value, the sensor detects it and generates an output voltage called the Hall voltage, which is represented by the symbol V suffix H. And let us have a discussion of the construction of all of its sensor. It consists of a thin piece of rectangular P-type semiconductor material. The material may be a gallium arsenide, indium and antimonide, or indium arsenide, and the device is placed within a magnetic field such that the magnetic flux lines exert the force on this semiconductor material, which deflects the charges, electrons and holes to either side of the semiconductor slab. This movement of charge carriers is a result of magnetic force they experience passing through the semiconductor material. As these electrons and holes move sidewards, a potential difference is produced between the two sides of the semiconductor material by the buildup of these charge carriers. Then the movement of electrons through the semiconductor material is affected by the presence of external magnetic field, which is at the right angles to it. And this effect is greater in a flat rectangular shaped material. This effect of generating a voltage by using a magnetic field is called the Hall effect, which is named after by the Edwin Hall, who discovered it during the year 1870. So this is the basic principle of Hall effect sensor. And to generate a potential difference across a device, the magnetic lines must be perpendicular 90 degrees to the flow of current and to be correct polarity, and it is a southward polarity. Now, the Hall effect provides the information regarding the type of magnetic pole and the magnitude of the field. So, the Hall effect sensors are used as switches for designed to be in off position when there is no magnetic field, and only in on position when it is subjected to a magnetic field of sufficient strength and polarity. This is now let us discuss the Hall effect sensors principle. So here you can see that Hall effect sensor which is connected. The Hall effect sensors works on the principle when a beam of charge carriers passes through the magnetic field, the forces acts on that particle and the current beam is deflected from the straight line path. Thus, one side of the disk becomes negatively charged and other side of the disk becomes positively charged. This charge separation generates a potential difference, which is the measure of distance from the magnetic field from the disk carrying current. So the typical application or main application of Hall effect sensor is the measurement of fluid cell in a container. The sensors are used for the measurement of displacement and reduction of position of any object. The Hall effect sensors may need signal conditioning circuitry, and they can be operated at 100 kilohertz. They have good immunity to environmental contaminants, and they have the ability to sustain in very severe conditions. So, which makes this Hall effect sensors widely used in many industrial applications. And this Hall effect sensors is an electrical circuit with current carrying disk is mounted in the casing. It is used for the measurement of fluid level in the container. Now, when the fluid level increases, the magnet will come close to the disk and the potential difference generates. This voltage triggers the switch to stop the fluid to come inside the container. In this way, the Hall effect sensor is used in the practical applications. Now, this Hall effect sensors, based on the types, how the output is connected, they are classified as, on the base of output, they are classified as digital Hall effect sensor and analog output type Hall effect sensor. Now, this is the diagram for analog output type Hall effect sensor. So, this analog output type Hall effect sensors contains a voltage regulator, Hall effect element, and an amplifier circuit. The output of this sensor is analog, and it is proportional to the magnetic field strength and the output of the Hall element. These sensors have a continuous linear output, and they are used as proximity sensors. So this is the waveform of the analog signal. And now the next type is the digital output Hall effect sensor. The digital output Hall effect sensor have only two outputs, that is on or off. These sensors have an extra element called skimmer trigger compared to an analog output Hall effect sensor, which is added in our circuit. Now, this skimmer trigger has a hysteresis effect and has two different threshold levels can be achieved with the help of the skimmer trigger. Accordingly, the output of the entire circuit will be either a high value or a low value. Hall effect switch is one of such type of sensors. These digital output sensors are widely used to limit switches in three-dimensional printers and positional interlocks in automated systems. The application of the Hall effect sensor, it is used for measuring the speed of the wheel or speed of the motor by determining the position of the crankshaft or camshaft in the engine system. So these Hall effect sensors composed of an Hall effect element in a permanent magnet, and it is placed near the tooth of the disc and which is connected to the rotating shaft. Now, the gap between the sensor and the teeth of the disc is very small. This gap between the sensor and the teeth of the disc is very small. Very small. And whenever the tooth passes near the sensor, it changes the surrounding magnetic field, which will cause the output of the sensor to go to a high value or a low value. So the output of sensor is a square wave signal, which can be easily used for calculating the RPM of the rotating shaft. So what are the different applications of Hall effect sensors? These analog Hall effect sensors are used for sensing the availability of power supply, motion sensing, sensing the rate of flow, sensing vibration, sensing voltage regulation, values, wheel speed reduction for the anti-lock braking system, direct current sensing in clamp meters, it is also known as tongue testers. The different applications of digital Hall effect sensors are sensing the angular position of the crankshaft for the firing angle of the spark plugs, sensing the position of the car seat and seat belts for airbag control, wireless communication, sensing pressure, sensing proximity, sensing the rate of flow, sensing the position of valves, sensing the position of lens. The advantages of the Hall effect sensor: it is used for multiple sensor functions like position sensing, speed sensing, and for direction of movements also. They are solid state devices which does not have any wear and tear since of the absence of moving parts, and they are almost maintenance free. It is robust and it is immune to vibration, dust, and water. Few disadvantages of Hall effect sensors are: they are not able to measure the current flow at a distance more than 10 centimeter. So a solution to overcome this is to have a very strong magnet that can generate a wide magnetic field. The accuracy of the measured value is always a concern of external magnetic fields, which may affect the values. And the third disadvantage is high temperature affects the conductor resistance. This will affect the charge carrier's mobility and sensitivity of the Hall effect. Thank you. On the whole, in this video, we have discussed the construction of the Hall effect sensor, working principle, and the types of Hall effect sensor. And we have discussed about the applications of analog and digital output Hall effect sensors and the advantages and disadvantages of Hall effect sensor. Thank you, everyone.